So this is section 1.2. So hopefully you've read section 1.2 already and know everything I'm going to do. Okay, so it's better to read it beforehand and then listen to the lecture after. So first we are going to reduce and multiply fractions. So, looking at this, 25 over 75, you should know the answer right away without me telling you what it is equal to. What is 25 parts of 75? 1/3. Okay. Now, one thing that we did learn along the way is to convert fractions to decimals. So what is this as a decimal? 0.33. Now that's rounding off, isn't it? Because what is it actually? 0.3 repeating, right? Or 0.33 repeating, and it goes on forever. In math, if you round off, you now have the wrong answer. It's now not accurate. So in calculus, if you have 1/3, you never write it as 0.33 because that's not the right answer anymore. Because then if you use that 0.33 for something else, you've now rounded off the new number. And in finance, that would be, finance is my area that I work in. In finance, if you round one number off at the start of the question, what do you think that might mean for a company? Millions of dollars, right? You can't round off. It's not accurate. We've taught you how to round off, but that's for things that are not important. And we're not going to do that. So you really need to know how to work with fractions so that you are using fractions all the time, not converting things to decimals. So we know this is 1/3. But why is it 1/3? Okay, 75 is 25 times 3. So what could we then say? What do we do? Right, and the word cancel is something that someone made up to show you that if you've got the number on top and bottom of a fraction and it's the same number and they're multiplied, that they don't need to be there. We can cross them off and it's still okay. But what's left on top? 1. Now, what do you think people do incorrectly? 0, right. So why is it 1? Right. Do you see it? Now, we're not actually canceling. That's not actually a thing. But it is a shortcut, and that's what we say. And you can say that. It's acceptable to say that you're canceling something in math. But what are we actually doing is saying that this can be broken up into two fractions, 25 over 25 and 1 over 3. 25 over 25, which is equal to 1. And multiplying by 1, now you're not going to do that ever again. But when we cancel something, that's what we're doing. So by crossing off that 25, we're saying it's okay because 25 over 25 is equal to 1. We can factor this fraction to be two fractions. And the 25 over 25 doesn't matter because when you multiply by 1, you get itself. So that's what reducing a fraction is all about. Same idea here. What do they have in common? 21 and 35? 7. So we'll write it as 7 times 3 over 7 times 5. We can then cancel out the 7s and we get 3 over 5. Okay? So that's one way. The other way that people talk about fractions is instead of saying canceling out, what is the words you use? Let's say we have let's do this. 50 over 55. So what is a factor that they have in common? 5. So words are important. Factor means something that you multiply or can be divided into the number, or two numbers that multiply to give that number. Those are the factors. So instead of looking at this as 5 times 10 and 5 times 11, what can you tell someone if you were telling someone in elementary school how to reduce this? What would you say to them? So we determined that 5 goes into both of these numbers because those numbers divide by 5. And if you were there yesterday, we talked about the divisibility rules. So those numbers divide by 5. So sometimes people will do this. Do you ever see that or do that? Say divide both by 5. That's acceptable as well. Okay? It's a little bit different way to look at it, but it's totally acceptable. Because why? Why can you divide both the top and bottom by a number? Right, because doing something to the top and bottom of a fraction is like dividing by 1. It's actually a little bit harder to see than this, because this looks like 50 divided by 5 over 55 divided by 5. People don't usually like fractions, but they're actually adding a fraction in when you're doing that. Does that make sense? So 50 divided by 5 is 10, and 55 divided by 5 is 11. Then you could, at some point, I mean, if the numbers are big, you might say, can this go further? Like, is there a number we can divide into both 10 and 11? And the answer would be no, so you're reduced the whole way. Okay, so when we multiply fractions, this is factored. So it's two numbers that are factored, and that means they are multiplied. Okay, so these are two factors of some larger number. How do we multiply fractions? Yeah, multiply the tops together. Oops. Multiply fractions. So that's saying, if you've got two fractions that are factored, separate, you can write them as one fraction, and you multiply the numerators, the top, and you multiply the denominators, the bottom, and you have a new fraction. So we can write any two fractions that are multiplied like that. Now what you're going to do when you can't use a calculator is not actually write this as 20 over 30. No, no, no. The numbers are easy here, but if they were larger, what you would be doing, so factored, that's like the number broken down into two numbers that multiply. Factored is simplified. You're always trying to simplify. Factored is simplified. If you multiply them together, it's called expanding, which means making it bigger. Doesn't multiplying numbers make it bigger? Not cool, because we're trying to simplify. So you actually want to reduce the fraction before you multiply fractions, never after. Always before. So right now they're already factored. Can any factors cancel? Almost. We could write it a little different so that we could cancel factors. Right? Or you could say divide the top by 2 and the bottom by 2. But let's write out the factors to see. So can the top be factored further? Yeah, 4 can be written as 2 times 2. Right? And can the bottom be factored further? Sure, 15 can be written as 5 times 3. So I took a number that's factored, already broken apart. I actually factored it further, because factoring is simplifying. Multiplying them together is making it bigger. We don't want it bigger, we want it smaller. Okay? Really important when you get into algebra. You don't want to do FOIL ever. Multiplying out, because you're making it worse, not better. Factored is better. So now we look and we say, okay, some things can cancel here. We can cancel a 2 and we can cancel a 5. We don't really need to rewrite it more than that to cancel them, and we're left with 2/3. Okay? So with big numbers, that's what you're doing. You're never going to multiply them. So as soon as you see like 2 times 3, don't write 6, because you're probably going to have to break it back up to 2 times 3 in the next step. Okay? Now that goes for multiplying. So just another example similar to that. Say we had 1/3 times 9 over 2 times 10 over 3. So 3 fractions multiplied. You could write this as one great big fraction and then cancel out what needs to be canceled. You can actually do it right from here if you know you're going to do that anyway. 9 is 3 times 3, and 10 is 5 times 2. So what cancels? We've got 2 3s and a 2. If there's nothing left on the bottom, what is there? Yeah, the factor 1 that we don't see. And we've got a 5 times 1 on top and a 1 on the bottom, so this is just 5. Right? That is a better approach than doing this, 90 over 18. 90 over 18, and then you would be factoring it to reduce it. Do you see what I'm saying? Really important in calculus. Don't multiply them out until you've tried to reduce them. Okay, so we can also get things like this, like a number times a fraction. This is not a mixed number. This is not 22 and 2 11ths. This is 22 times 2 11ths. And we're not actually going to use mixed numbers in calculus, so you won't see it ever, and you don't want to write them either. So this is the same as saying 22 over 1 times 2 over 11, which is 22 times 2 over 11. If you want to put the 1 in there, you could. What's going to cancel here? 22 can be broken down. So the 11s cancel. Anything else? Nope. So we've got 2 times 2 on top and a 1 on the bottom, which is just 4. Okay, so let's go into dividing fractions. We're going to actually do something similar, not multiply them out and make them bigger. We're going to try to simplify first and then get our final answer. Okay, so dividing fractions. What's the rule? So one thing in math that makes some students not as good in math as other students is that you need to have words to your math. You can't just remember what a rule looks like. You actually have to put it to whatever your language is. So here, English. So when I say what's the rule or how do we divide fractions, you need to have a sentence that answers that. And then every time you see fractions that are divided, that sentence appears in your head. So for multiplying fractions, I would say, so what's the rule for multiplying fractions? And you would say, you probably wouldn't say numerator and denominator, but if you would, that's great. You might say you multiply the tops and you multiply the bottoms. That's your sentence. And that's also your rule. And that rule needs to be in your head, not something you read on paper. Right? And every time we say, okay, we're multiplying fractions here, what's the rule? You multiply the tops, you multiply the bottoms. I say it over and over again because that's in my head and I'm good at math. So what's the rule for dividing fractions? Yeah, so you might have a different sentence than me. I say, when you divide fractions, you multiply by the reciprocal. But I know what I'm talking about. The reciprocal means flip the fraction over, but which fraction do you flip over? The second one. So you might have more to your sentence if you're not good at it. You might say, to divide fractions, you write down the first fraction and flip the second one over. That might be what you say. But you need something in your head that is in your, whatever language you think in, that you say that will prompt you what to do, okay? And that goes for everything in math. So, when you divide fractions, so here I write the rule down like this. This does not mean anything unless it has words to it. So here we're dividing two fractions. So to divide two fractions, you write down the first fraction and multiply by the reciprocal of the second. And you could say flip over the second, whatever you want to call it, as long as it makes you do the right thing. Right? So you might say, write the first fraction and multiply by the reciprocal of the second. Right? Something that's in your head. And you might use different words, flip over the second and multiply, whatever. Now, a lot of times, teachers say these things, but you never actually write them down as a rule. What you write down as a rule is that. And then you're trying to remember what that looks like rather than what it means. Okay? So that's one thing that some people do that doesn't really help. Okay, so if we had, for example, so just an improper fraction, the top is bigger than the bottom, an improper fraction. Normally you'd write this as a mixed number, but in calculus we do not use mixed numbers, so we're not going to do that. We're going to reduce this fraction, just like we did already. And that's not dividing fractions yet. But a fraction itself is a division, right? How do we write that division? You agree with that? So in the car the other morning when I was teaching Emma how to divide fractions, or to simplify fractions, that's what we were doing, and she said, a fraction is dividing? So she's actually good at fractions, but she missed that at some point. Right? And when you start missing little things all the way through school, that makes everything complicated. All right, so let's say we have 1/4 divided by 2/5. So we would write the first fraction and multiply by the reciprocal of the second. Easy enough. And then we do the same thing. We say, does anything here cancel? Can we have common factors there? In this one, no, so this will be 5/8. So you can expand because there's nothing to cancel. Two-thirds divided by 1/6. Write the first one, flip over the second one, and then multiply. The 6 would have a 3 in it. So I would say this is 3 times 2. So we get 4/1, which is 4. Five divided by 1/10. So one of them doesn't have to be a fraction, so we would say 5, that's like a 5/1, times 10/1. So 50/1, which is 50. Does that make sense? Okay, so nothing hard yet. What about the other way around? What if we had something like 3/4 divided by 2? So we're not actually even dividing by fraction here, but every number is a fraction. So this is the same as saying divided by 2/1. times, change the sign, and flip it over. So we have 3 times 1 over 4 times 2. Nothing cancels, so 3 over 8. Okay? Which one of these? So I've written some different cases here. Which one do people screw up the most? The last one. Yeah. They put, usually the 2 ends up being multiplied instead, and they get 6 over 4. A lot, that happens a lot when you divide by a number that doesn't look like a fraction to start. Now, the problem being that this isn't actually how you ever see it in calculus. You'd never see anything that looks like this because they don't write a divide sign. They write it as a fraction instead, right? So what they actually would look like is more like this. Two fractions divided, that would appear in calculus. So the rules are the same. What happens, though, is because this looks a lot more complicated, up here in this first one, no problem. You wrote the first fraction, you flip over the second one. Here, same idea, but all of a sudden people start not knowing what to do. Okay, but it is the same. It's a fraction divided by a fraction. So you write the first fraction, which is the top, and maybe you have a different sentence for this. Or maybe you say, what does this question look like? It looks like a fraction divided by a fraction. So when you divide fractions, you write down the first one, or the top one, and multiply by the second one flipped over. Okay, now does this simplify? It looks like it might. 10 times 3 times 10. 21 is 7 times 3. So some 3's cancel. Nothing else? 10 times 10. 7 times 7. And you leave it as an improper fraction. You don't make it into a mixed number. Okay, here's one for you to do. Okay, so what does this look like? The top fraction is like a 2 over 1. So 2 over 1 divided by 3 over 4. So you could rewrite it. That would be another approach. Rewrite it first, and then once you rewrite it, so this is 2 over 1 times 4 over 3. Nothing cancels, so we can multiply it 8 over 3. Okay, I've got 2 more, like this. So this 1/5 divided by 2, and the second one, 3 over 20 divided by 6 over 8. Now, I just noticed I've got my equals going across, right? And I said not to do that in the first section. You can still stick with the equals going down. That is usually a good approach if you make silly mistakes. The problem with doing this way, I'll show you in a second when I'm done these two, is that you have to make sure that everything in between is still equal. Okay, you can't be writing one thing down. It happens a lot in... You say, okay, I want to divide by 2, and then on the next line you say, oh, and I was supposed to add 5, so then you write plus 5, and now it's not equal anymore, because the one before didn't have the plus 5. Equals going down is a better way for if you make silly mistakes a lot. So this is divided by 2. So that means when we multiply, it's multiplied by 1/2. Be careful of that. This is divided by 2, which is 2 over 1. When we flip it over, is 1 over 2. And this one, 3 over 20 times, flip it over, 8 over 6. Three times 4 times 2, 4 times 5 times 3 times 2. Do you see what I'm doing when I do that? Just breaking them down. I'm actually looking at the top and saying I want to factor them so that numbers are in common as much as I can get. So I said, well, the 8, there's a 4 that goes into both of these, 8 and 20. So the 8 I wrote as 4 times something, and the 20 I wrote as 4 times something. I saw a 3 and a 6, so I broke it up that way. 2, 2, 4, 4. Okay, so what are we left with? 1 over 5, and what half are you going to do on a test? And not write 1 over 5, half of you. And I'll say, I said that in class, I remember saying that. I also remember telling them half of them would get it wrong. What is half of you going to write? Any ideas? Just 5. Just 5. So watch for that sort of silly mistake. You say, okay, everything canceled except for the 5, and you write a 5, and then you go on. Okay, so